In the previous video, we've seen that for a given interest rate of let's say 7% and a principal amount of $400, the amount that you have after 1 year is given by this thing here, and it turns out that this block here is the number E. So in this video, rather than looking at it at 1 year, we are going to look at it for T years, so multiple years at any given interest rate. So so remember, this R here is already expressed as a decimal, so 7% would be this thing here. It would be expressed as a decimal. Well, in this video, we're going to look at it for a principal amount of P, interest rate of R for T number of years, and then the amount that you have in the bank will be given by this. So so let's start. So at the start of in the previous video, we've seen that at the start of the year you have an amount of P, and then after 1 year, if you compound it n number of times, we've seen that it will give you this in the previous video. If you compound it n number of times, so for example, if you compound it every month, then this would be 12. So the amount of money you have in the bank, if you compound it 12 times a year, it will be 12. If you want to compound it every week, then 52. So this would be the amount of money you have in the bank. If you want to compound it every day, then 365, and so on. This thing here tells you the amount that you will have in the bank for the first year, depending on the number of times you want to compound it. So this is for the first year. So for the first year, you will have this amount. So let's now look at it on a year-to-year basis. So let's start again here. At the start of the year, you will have an amount of P. So after year 1, the amount that you have in the bank will be this times this, which will give you P 1 plus R over N to the power of N. And then at the start of year 2, this will be your new 100%. It will be your new 100%. And then at the end of year 2, you will have this much of an interest. So so the amount that you have in the bank would be this times this. So that would be P. And then notice that this block here is exactly the same as this block here. So so the amount that you have in the bank would be this. 1 plus R over N to the power of 2N, because this is exactly the same as this. Remember, x to the power of A times x to the power of A, that would be x to the power of 2A. So that's where this thing here is. Anyway, this times this would represent the amount of money you will have at the end of year 2. Later on, we can take the limit as n tends to infinity, meaning we're going to compound it n number of times as n heads towards infinity. Or well, the amount you have in the bank after 2 years will be given by this. Now, at the start of year 3, hang on. At the start of year 3, you will have this much. So this is at the start of year 3. At the end of year 3, you're going to get this much amount of interest. So you've got to get this times this. So hang on. So the amount that you have at the end of year 3 will be P, and then 1 plus R over N, and then this times this would be 3N. And then at the start of year 4, this will be your new 100%. This will be your new 100%. So this is the amount that you have in the bank at the start of year 4. Well, at the end of year 4, you would have to get this times this. So so that will then give you this. Notice that this matches up with the year that you're in. So if you want to compound it T years later, so it will be ... So at the end of year T, at the end of year T, you will have this much. So this is the amount of money you have after year T. And it does depend on the number of times you want to compound it. If you want to compound it every month, then 12 would go into the N, 12 would go into the N. If you want to compound it every day, it would be 360 into the N and 360 into this N. So the amount of money you will have in the bank, it depends on, it's approximately this much. It depends on the number of times you want to compound it. So if to get a true accurate answer, you let n tend to infinity, meaning you compound it every nanosecond rather than every day or every year or every month or whatever. You let n tend to infinity, meaning you're going to continuously compound it every nanosecond. Well, the amount of money you have if you compound it every nanosecond will be given by this much here. So now let me think. Now p is a constant. So when you're trying to take a limit of the thing that contains a constant, the constant's you're able to take the constant out. So that will then give you a constant times this thing here. And then remember indices a to the power a, x to the power of a to the power of b, that equals x to the power of ab. So whenever you get given this, which we have here, you can you can actually jump to this stage here. So hang on, let me think. Hang on, where were we? So hang on, let's start again here. So this p here is a constant, so you can take the constant out. That will then give you this thing here. So so now we can rewrite this thing here as I'm just going to move the t out here basically, so it looks like this. You are able to do this. I've done one video explaining why you're able to do this. So track back to one of the early videos. So this thing here, you can think of it as being one block. So that's this thing here to the power of t. So you push the t out basically. So now that will then give us this thing here. Remember the definition of E. The definition of E is given by this. I'm expecting you, well, sooner or later you've got to memorize this by heart. This is very important. So anyway, the problem here is that we want to translate this into something of this form, because here you've got 1 over a bubble, and then here you've got a weird number here. So we've got to somehow turn this into something of the form 1 over x. So we would use this. We would always use this trick. Let this thing here be 1 over x. So later on we can put this into here, and then that will give us this. So let's start again here. Translate this. So let this be 1 over x. Take the reciprocal of both sides. That will then give you this. Get n on its own. So times both sides by r. So that will then give us this. So let's translate it now from here. Look at this bit here. This thing here, well, that's this thing here. So we can put this into here. That will then give us this thing here. And then if you look at n, what is n? Well, n is this thing here. N is this thing here. So we can put this into here. That will then give us this. Okay, so this whole thing here will then become this. But now we are looking, rather than looking at this thing here, we have a new bubble here. What is up here? What n is heading towards infinity, but we are working in terms of a new bubble, this x here. When n up here, when n heads towards infinity, what is happening to x down here? We need to think about this. So looking up here, looking at it up here, as n tends to infinity, what is happening to x as n heads towards infinity? So you want to know what's happening to x. Look at x here. Look at x here. As n gets bigger and bigger, what is actually happening to x? Well, as n gets bigger and bigger, x will also get bigger and bigger. So this is just a trick that we normally use. So here in this case, n gets bigger and bigger, x also gets bigger and bigger. Okay, so now we can push, this is just a constant, let's push it outside. That will then give us this. Now we've got something of a form that we recognize. This is E here, this is E. So as n heads towards as x heads towards infinity, we can just put the number E into here. So that becomes this. So that's your formula. If you want to know the amount of money you have in the bank, and you want to compound it continuously, then it will lead you to this number E. So whenever you have a population growth or anything that grows by a percentage of an amount, and you want to compound it continuously, then eventually it will lead you to this thing here. Okay, so E occurs when you have something that grows or decreases by a percentage of an amount, and you want to compound it continuously. The number E will creep into here because of this thing here. Okay.